All right. This is 2018 AB for response 1, and we are doing AP review. This is a calculator problem. So people enter a line for an escalator at a rate modeled by the function r, given by r of t equals this entire giant monstrosity from values of t that are 0 to 300 inclusive, and then just 0 after t is greater than 300, where r of t is measured in people per second, and t is in seconds, meaning that after 300 seconds, meaning after 5 minutes, no one else is getting on the escalator. People are, the rate of people getting on the escalator is 0 after 5 minutes. Cool. As people get on the escalator, they exit the line at a constant rate of 0.7 people per second, or person per second. There are 20 people in line at the start when t is 0. Part A, how many people enter the line for the escalator during the interval from 0 to 300? So the big thing here is this is going to be one of those rate in, rate out problems, right? So this is the rate in, right? This is the rate in, and we were given that the rate out is 0.7 people per second, right? Like that's the rate people are getting off of the escalator. So there's people getting on this escalator, here's my little ridiculous escalator. There's a rate that people are getting on, right? That's the rate, and there is this 0.7, that is the rate they're getting off, right? So they get on the escalator, they get off the escalator. Cool. So whenever we're handed a rate, if we want to find the quantity of people, we integrate, right? So if we want to take a rate and turn it into a quantity, we integrate. So part A is going to be the integral from 0 to 300 of r of t dt. Now, you don't have to write this ugly monstrosity for r of t because you're allowed to use the notation that is handed to you. So that's all they need to see on the AP, and then they need you to find that value, right? That's what your calculator's for. So I put this whole thing in as y1. I used x's instead of t's, right? This is my y1. And what I'm going to type in my calculator is function integrate y1 with respect to x from 0 to 300, right? So my calculator is going to do the heavy lifting. So there's my y1 with the ugly monstrosity that I have, and I quit out of that, and I do math 9, right? I'm going to go to vars, y-vars, and pick function. Sorry, my calculator is on low battery, which is a thing that under any other circumstances I would yell at one of you guys for having an issue with. But my calculator is on low battery, and I have done nothing about it like a terrible human. I'm going to deal with it shortly. Hopefully it doesn't die on me. All right. So I integrate, and I get a nice even 270, and so I think to myself, well, that's weird. I probably could have done it by hand, and maybe you could have, but why? So 270 people, and that's it. Right, you're not rounding, you're not truncating, it's 270 people. Oh, as a side note about your calculator, when its batteries are dying, your calculator has, under these 4 batteries, it has a little teeny backup disk battery. That disk battery is what keeps you from losing all your RAM and your programs and stuff if your calculator 4 batteries die. So when your calculator is flashing low battery, it's actually running on that disk battery. And when the low battery signal goes, like warning goes away, that means that you have completely killed your backup battery and you've lost everything on your calculator. So when your calculator flashes low battery, please actually change it. Again, I am not the person who's done that right now because mine is totally low battery, but it is what it is. So that's my part A. Part B. During the time interval from 0 to 300, there are always people in line for the escalator. How many people are in the line at t equals 300? Right, so again, we know that 270 people got in the line, right? We know that there were originally 20 people in the line, and we can calculate from 0 to 300 how many people got off the line. So when we go to do part B, we're actually going to use some information from A, right? So here's the logic. In part B, we know that at the start, there were 20 people in line because they told us that at time 0, there were 20 people in line. Plus, we know that in the window from 0 to 300, the number of people that entered the line was 270 because we just found that in part A, right? And then we need to subtract the fact that in that 300 seconds, 0.7 people per second got out of the, off the line. Sorry, my bad. I should actually put that minus the people that got off of the line, which is this 0.7 times 300, right? So 0.7, so a 7 times a 3 would be a 21. So what we're looking at here is a 210, right? So we end up with 290 minus 210. You can type that in a calculator, it's fine. So you end up with 80 people. So there are 80 people in line at 300. Cool. So again, we take the amount we started with. This is how many people we gained. That's how many people got in line, and that's how many people got off the escalator or out of line. Cool. Part C. For t greater than 300, what is the first time t that there are no people in line for the escalator? Well, that's actually pretty easy to figure out, because here's the thing. We know that there are 80 people in the line when they close the front of the escalator. I don't know what kind of escalator this is that they don't let people get on the escalator anymore, right? But we know that at t equals 300, there are 80 people in line. We know that they are getting off of the escalator at a rate of 0.7 people per second, right? There's 80 people. We need to know how many seconds it's going to take for that number of people to disappear. Well, in 1 second, we get rid of 0.7 people, right? I put the 0.7 people on the bottom so people would cancel. I divide 80 by 0.7, and I get that that's going to be 114.286, right? But that's the seconds after 300 seconds total. So if they want the total number of time, the answer is t equals 300 plus that 114.286, which is approximately, and I think it's either a 6 or a 5, depending on if you round or truncate, right? So I get t is approximately 414.28, either 6 or 5 seconds, right? So again, I can figure out how fast those 80 people leave the line because I know they're leaving at a rate of 0.7 people per second. Last part, part D. From 0 to 300, at what time t is the number of people in line at a minimum? To the nearest whole number, find the number of people in line at that time and justify your answer. Okay, so here's the thing. We have this rate, right? And this is when we're going to lean a little bit on the calculator, right? So first thing we need to do is if we want the minimum number in line, right? If we want the minimum number in line, we need to find the critical points by finding its derivative. So I'm just going to call L of t the number in line, right? That's the number in the line. Okay, that means that L prime of t is the rate at which people are getting in the line, which is R of t, minus the rate at which they're getting out of the line, which is 0.7, right? So this is the thing that is going to give me my critical points, right? So if I want the critical points, and again, I used L of t as my total number in line, right? And there are other ways to think about it, but so I want the minimum value of this. So my critical points are going to happen when L prime of t is 0, which is when R of t equals positive 0.7. And what you'll find is that's always true. The extrema of a function like this always happen when the rate in is equal to the rate out. So I can use my calculator to find these times, right? I'm going to put this in as y1 like I already did. I'll put 0.7 in as my y2, and I'm going to second calc intersect. And when I do that, I'm going to get a couple t values, right? So when I go to my graph, and I know that I should change my window ahead of time, right? I know that I'm looking at x values, like t values from 0 to 300, so I might as well go ahead and change my my values now to have a very large window, and I'm looking for points of intersection, right? And I'm going to get a couple of these points. So here comes the line coming through, right? I used small y values, I only went up to 5 because I was looking at 0.7. So I do second calc intersect. Now, I always like to start with the one that is the furthest to the left and then work to the one to the right. You don't have to, but that's my preference. Okay, so I'm going to enter, and I'm going to get the first value as t equals 33 point something, something, something. I don't think I agree with that. Hang on. Oh, I'm sorry, I do agree with it. I just misread something. My bad. So I get t is this value, right? So the first point of intersection, which we can call t sub 1, is 33.013298, etc., etc. I'm going to store that as a. So I'm going to call that a, which means from now on, so the way I do that is I quit out, I type in x, and you'll see that number appears, and then I store as alpha a. That way I never had to type it, but I have it, right? And I make a note for the AP that that's what I'm going to call it. I'm going to call my t sub 2. What happens when I do the second calc intersection. Okay, second calc intersect. Oh, so see how the curve goes out of the way? If I press down, it'll put me on the line and I can get there a lot faster. So I'm going to scroll over, second calc intersect, enter, enter, enter. and I get an x coordinate that is 166 point stuff, right? So 166.57472, and I'm going to store that as b, right? We'll call that b. So when I quit out again, right, I hit x, and now x is that number magically, and I store that as alpha b. So now I have those numbers. Okay, so here's the idea. These are the only critical points, right? There's no spot where this doesn't exist in the window from 0 to 300 because R of t exists from 0 to 300, and so does a 0.7. So there's no does not exist, and there are endpoints. So the only so there's no place where L prime of t does not exist. I can cross that off of my critical point list, but there are ends, right, at t is 0 and 300. So the argument here is that the only possible candidates for the minimum value are these 4. So the easiest way to find this is to just find the value for these 4 and then identify which one is the smallest. The funny thing is we already know 2 of them. We know that the number of people in line at t equals 0 is 20, and at 300 it's 80. So we can already rule out the 80 because it's bigger. I can find these 2 other values using integration, and that's what I'm going to do. So let's walk through this now. In order to find the total number of people in line, right, so we've seen that my number of people in line, right, should be the number of people that started in the line, which is 20, plus the number of people that enter the line, right, which would be the integral from 0 to whatever time t I'm using of that r of, and I'm going to use x dx because you can't use the same value as a bound that you use inside the integral, minus this 0.7 times however much time I use, right? That's the number of people in the line, right? So I can make my calculator do pretty much all of this, right? So the times I need, right, my critical values were when t was 0, when t was the thing I called a, when t was the thing I called b, and when t was 300. Well, we already know the value, the number of people in line, right, was 20 at t equals 0, and it was 80 at 300. In order to find these two, I'm just going to plug into this formula with a, right? I'm going to do 20 plus function integrate y1 with respect to x from 0 to a, right, minus a 0.7 times a, right? I'm going to slide this guy over so you can see him. That's all I've got to do. And then when I want to find this guy, I'm going to do the same thing, but I'm going to actually hit second enter and replace these a's with b's. So if I do 20 plus math, oh, there's my calculator low on batteries. See, you should replace it. So if I do 20 plus math 9, y1, comma, with respect to x from 0 to a minus 0.7 alpha a, that's going to give me the first value, right? Which tells me that there are only 3.803 people in line at that moment. And if I hit second enter, I can be really lazy and just go fix all the a's and make them b's. So I can type over a with an alpha b, I can type over the other a with an alpha b, and I can hit enter, and that's going to do it for me. And I'm going to get a 158.070, right? So same thing, but with b's in those two spots, right? Those were b's, and it was the same thing. So what I want you to notice is that then it's pretty easy to find my minimum number, right? Sorry, I went the wrong way. So the min happens at what I called a. So the minimum number is, and they said to the nearest whole person, so 4 people at t is approximately the thing that I called a, which I would have on my paper if I still had a paper, but I don't because I erased it for you. So at this time, right? So that's what I have to answer. Again, the only possible critical points happen in these rate in and rate out problems. The critical points are when rate in equals rate out every single time. And at the endpoints, but the endpoints are usually the easy part.